Last class we said, why should we use this UDP echo client? This echo client, why should we use this echo client? We can write our own client. So our client is we're going to write it in UDP client.c. Okay, that's what we did. And we saw that by using Wireshark we could actually verify that our code, our UDP client, work very similar to the original Netcat program. Okay, so there is really no difference between the Linux UDP echo client and the client that we wrote. Of course, it does not have many error checks, but essentially it exactly does what this Netcat program also does. This is the program that we wrote. I think you would remember. I think you can see this program. This is what we did. We remember that we first require a socket because socket is an endpoint in communication. This is the only way the application layer can directly talk or connect to the transport layer. Okay, so we just saw this and we said, okay, that's the reason why we are going to create a socket. And after creating a socket, we said that this socket would support the datagram type, because we are not doing TCP, we are using UDP. And remember, what's the full form for UDP? User datagram protocol. So since it's a datagram type of socket, that's the reason why instead of sock stream for TCP, we are using sock dgram. That stands for datagram. That's the first step. What's the second step? The second step is to identify the details of the server. Okay, and what is the detail of the server? The first requirement is, okay, the very first requirement is, what is the IP address of the server? So we are really interested in the IP address of the server. We said, okay, this IP address here, okay, is the local host. And what is this IP address? 127.0.0.1, because this is the IP address of the local host, the current host. Okay, so we got this IP address. And second, other than IP address, what you require is the port number of the server socket. You have to connect to this particular port number. And as we have been repeating, 7 is the well-known service or well-known port for the echo protocol. And that's the reason why we have to know two things about the server for successful connection. Number one, we have to get the IP address, which is 127.0.0.1. And then second, we have to connect to the corresponding port number for that process. And the port number here is 7. Okay. So if you look at this code, that's what we did. We said the server should be 127.0.0.1 because it is the local host, and then the server port has to be 7 simply because 7 is the reserved well-known port for the echo protocol. Then we said step number 3 is that in order for this communication to happen, you have to fill up what is called the sock address type. Okay. So now there are how many fields there? There are 3 fields there. The first one is family, and family has to be fixed AF, okay, underscore INET. And what this stands for? This stands for IP version 4. So if it is AF INET V6, then it will be for IP address version 6. Okay, that's number 1. Second is the port number, the server port number, and this server port number is, we know, the port number 7. Then what is the corresponding server IP address? Server IP address, we already know, it is 127.0.0.1. That's what we did. Once we have filled up all the details of the server, meaning the IP address using this line, and then this port number using this htons function, we finally got the details of the server ready. Once that was done, then we sent this, we got this buffer, the data that we are going to send. We are going to send a hello, and we simply call the function send to send the data. Okay, we just say send to and we want to send the data. Of course, after we send the data, remember, it's going to give you a response also. This response in yesterday's exercise we could actually watch using this Wireshark. Okay, but it's not required. You can actually get the response directly. The response that is being sent by the server, you can also receive in the client. And in order to do this, we can get another function called receive from. Okay, that's another function that you can use. So you can just go here and let's get a terminal here. Okay, we already know that see, there is a echo response. That's the first packet sent from the client to the server, and response packet, echo response packet coming from server to client. So here you can, in the client, inside this code, you can actually receive the packet that was sent by the server. You can do this, is not a problem. You can say man receive from, I think. Okay, so this is the argument. You can just receive this. You can just use this thing. Okay, that's the function call. So that's the system call. So let's put it here. Okay, you can just receive from. Okay, so first is the socket, and socket, remember, is SD, socket descriptor. Okay, you have to get a buffer, say get a reply buffer, say server message. Okay, let's call this server message. Let's give it a range of 200, probably 100. Okay, so the message that we are expecting to receive from server, the maximum size we are expecting will be like 100 bytes or 100 characters. You can just pass it here. You can just pass this server message here, and the size of the maximum size of the buffer is size of server message. You can just do this. Flags, of course, is 0. Okay, and both these pointer values, source address and address length, you can just say null. Okay, it's up to you. And of course you have to get the size also. So message size. Okay, that's what we're going to do. So remember, what does receive from do? If you look at the man page, receive from is to receive a message from a socket. And what is the socket that we are talking about? We are talking about the server socket. And what does server socket return? The server socket returns the exact same thing, except that it will return the exact same data that we have sent. It will be hello, but hello was sent by the client first to the server, packet number 1. We are going to capture the second packet that is coming from the server to the client. Okay, that's what we're going to do. So we have done this, and now we have called this function. And why are we doing this? Let's call it step number 5 with the receive reply from the UDP echo server. This is what we are going to do. And once we have received it, you can just zero out the server message size. You can just zero it out. Okay, and then you can just printf message received from server. Okay, and just put this value. What's the message that's received from server? It will be in the server message buffer, cc udp client.c. Once you have compiled it, now you can just run it. And remember, the server is running already, so just connect using the client. So in order to do this, you can just cc udp client, and you can say -o udp client. Okay, so now we have ready. We have this UDP client that we have just written. And remember, what is our claim? Our claim is that whether you write it as netcat or whether you do it UDP client is the same. So you send a message, we get a reply. So let's now run it. Let's run /UDP client. Let's run this UDP client. So now how many messages we expect? One that will be sent from the client to the server, another message from the server to the client. Okay, so it is going to, if it is correct, then it's going to happen very fast. Okay, first immediately a message will be sent hello, and immediately the server is going to reply. So let's do it now. Let's do an enter. 1 2 3 enter. See, what does it say? Client sending message to server hello, and message received from server hello. Is it not? So it's the exact same behavior. So, and that's what echo means, no? The client sends a message to the server saying hello, and the server replies with the same message hello. That's how, as you can see from the picture, the first packet is the one that we have sent. This is the first packet. See, it has sent a hello, and then the server hellos back again. See, this is sending this hello data back. So you can see this hello coming from the server. So I've just verified that this UDP client is a very simple program, but it seems to work correctly. So we have already written a lot about how this program works in the previous class. Today we are going to do something else. So we just delete all this, guys. Okay, we just forget about this guy also. Okay, just this function. What does this function actually do? What does this h2ns function, what does it actually do? Okay, let's see. h2ns is going to return the destination port. Okay, h2ns is going to return the, if you are given a server port 7, it will return a, h2ns will return a destination port. And remember what we did yesterday? We said, okay, we can do a man of h2ns, host to network byte order, and we can talk about this. And what does it say? It says h2ns, you just take this thing here, you just copy this h2ns, let's put it there. What does h2ns do? h2ns is this function. And what does it do according to the man page? It is a function that converts from an unsigned short integer to network byte order. Okay, that's what, this is the first time we are coming across this particular term, network byte order. So in order to understand this network byte order, we just open this, open a man page, open any web page, go to Google. Okay, and please go and type, you can just go through this and you can just look for Endianness. Okay, there's a huge Wikipedia on Endianness. You can just go through this. See, this talks about a huge number of, you know, Endian example, little Endian, big Endian. You can just go through this. What is Endianness? So remember this Gulliver's Travels? Gulliver's Travels, there were two groups, na? Two Lilliput tribes. Okay, and they were always fighting. And what were they fighting for? They were fighting for an egg. They were fighting for an egg. Egg matlab kya? Anda. Na? One group believed anda should be broken from a little end. And what is the next group believed? Anda should be broken from large end. Okay, so remember what is the argument? Anda should be broken from little end. Those guys were little Endians. And anda should be broken from large end. They were big Endians. So now, just like Lilliput had two groups, little Endian and big Endian, in modern processor inside the computer, you have little Endian and big Endian. Okay. Now, if I just write a number, if I write it in decimal, no, if I write, say, suppose 1, 2, 3. Which is the least significant number? Which is the least significant digit? 1 or 3?
3, sir.
3. And what is the most significant digit?
1.
1. Of course, wahi to hoga. Isn't this the same? This thing here is the least significant. Let's write it down. Least significant digit. Okay. And what is 1? 1 is the most significant digit. ऐसा है ना? So now this 1 is the most significant digit, सबसे बड़ा, क्योंकि place value के हिसाब से 1 means 100, no? And but 3 means तो 3, and this 2 center में means 20, so that's why it's called 100, 123. So now for binary also is the same thing. ये लास्ट वाला जो बाइट है, दिस इज द लीस्ट सिग्निफिकेंट डिजिट और दिस इज द लीस्ट सिग्निफिकेंट बाइट, और ये वाला 0 है, व्हाट इज दिस इज द मोस्ट सिग्निफिकेंट बाइट. इसमें कोई डाउट है क्या? I think this is okay. This is okay, no? So now look at in little Endian, see where it is placed. If you take the least significant number, where do you put it? This A जो जहाँ पे डाला है, this thing. What is this? Is this the smallest possible memory address or the largest one?
Smallest, sir.
It is the smallest. So it's the smallest memory address. ऐसा है ना? So Little Endian में what's happening? You take the least significant digit or least significant byte and put it in the smallest possible memory address. That's what you do. So you take the smallest one, you take the little end and then put it in the memory. That's why it's called Little Endian. अब यहाँ पे जाके देखिए, if you look at this guy here, okay, this guy here, what is this? We have already seen this portion, no? 0A, what is this? 0A is the most significant, 0A is the most, this is the most significant, it will be a byte, no? Rather than digit, we call it a byte, okay? So this is the most significant byte, this guy. And where is this put? A mein. And what is A? A is the smallest possible, smallest memory address or the largest possible memory address? A. Just like here, no? It is the smallest memory address. Is it not? This guy. So what is happening? In Little Endian, you take the little end and put it in the memory. Okay, that's why it's called little Endian. And in a big-endian processor, you take the largest possible, the most significant byte and put it in memory. That's why it's called a big-endian architecture, is it not? So all processors in the world right now, execute in either Little Endian mode or big-endian mode. Little Endian mode or big-endian mode. So what is Little Endian? Little Endian processor means what? The little end, meaning LSB, will be stored first in memory. What is big endian? Big endian means the big end, meaning MSB, most significant byte, will be stored in memory first. What happens when client is running on Intel processor, Little Endian? Okay, what happens when client is on Intel processor and server is on Motorola processor? This is big endian. देखिए, when we just did the client server program, remember? But that time to our processor, our program was running at the same place, no? ये मेरे ही laptop में both the server and the client were running, so there was no problem. But now we are considering a scenario where client is on the Intel processor, which is a Little Endian processor, and server is on the Motorola processor, which is a big endian processor. They are exactly ulta of each other. So if I send HELLO, the Motorola processor will say, oh, this guy is sending O. So Intel processor mein, when we send HELLO, I will say HELLO. That's what he said. So he says, big endian में क्या receive करेगा? OLLEH. उल्टा नहीं हो जाएगा क्या?
Yes, sir.
It will be exactly ulta, na? And why is it ulta? Because both the processors are running totally different architecture. एक Little Endian है, एक big endian है, and both of them are exactly ulta of each other. How can they talk to each other? Suppose I am talking in Bengali and I am talking to a person who is speaking Malayali and he doesn't understand Bengali and I don't understand Malayali. Can the communication happen? There is no chance, no? Because both of them are talking totally different languages. Then what is the solution? Translator, right? Or translator. Or you can just have this. That's one solution. What is the other solution? Okay. So this is the exact same problem, no? A speaks in Bengali. B speaks in Malayalam. Then what is going to happen? Communication fail. Communication will completely fail, no? They are not able to understand each other. Both of them are speaking in totally different languages. So what's the solution? Solution is find out the common language between A and B, between the client and the server. Okay. Suppose A can also speak in English and B can also speak in English. Then A speaks in Bengali accented English and B speaks in Malayali accented English. But anyway, communication has succeeded. Is it not? Because both of them, एक तो बंगाली में है, वो मछली खा खा के इंग्लिश बोल रहा है, और दूसरा मलयाली है, वो कोकोनट खा खा के इंग्लिश बोल रहा है. But both of them are speaking English, no? So there is any problem. Both of them are able to understand each other. So what's the solution? The solution is to find a common language. The solution is to find a common language. The other solution is to find a translator, and that's going to be a big problem. So we say, okay, A and B just decide, okay, both of them know English, let them speak in English. Is this okay?
Yes, sir.
Okay. So now look at the processors. Processors mein what are the two kinds of processors? One is little Endian, another is big Endian. And both of them are passing through the network. Both of them are passing through the network. Okay. So you've just said, no, fine. So we are saying that this is the client and this guy is the server. Okay. So this is the client and this guy is the server. This guy is little Endian. This guy is big Endian. And both of them have to talk their different languages. So how are both of them going to communicate to each other? कैसे बात करेंगे एक दूसरे से? They have to use a common language, and this common language will be where? This will be the language of the network. No, this network should have a common language. So let's pick up another color here. Let's take green. So now that's the reason why. It's important that this network should speak in a common language, and that common language in computer networks, the common language is big-endian. Okay, what is the common language? What is the common language? Big-endian. Okay, and this big-endian is also sometimes called the network byte order. Whether the client is little Endian or big-endian really doesn't matter. All communication in any network in this world has to go the big-endian mode, meaning it would have a network byte order. We just said that in order for this communication to succeed, just like A and B will speak, we now know that client should speak. Client, it really doesn't matter, should speak little big-endian, and server should send data in big-endian. Big-endian means network byte order, and server should receive data in big-endian network byte order. Since client and servers, both of them are talking in big-endian, the network byte order, now there is no problem. Both of them have the same common language. So the host to NS, what does it do? It converts from the host byte order, big-endian or little Endian, to the network byte order. And what is network byte order? Big-endian. So now we have to see that H2NS actually is a conversion function. What it does is to convert the data, convert whatever is given argument from the host byte order to network byte order. And remember, what do you mean by network byte order? We already know it is big-endian. Okay? If you don't do this, then all communication is going to fail. Okay? Everything will compile right, but you will never get the message back. Okay? It will not work anymore. Say for example, okay, if we don't do this host to NS and server port, if you try sending the message, nothing is going to go. That's the reason why this function is such a requirement. Even though it's a very simple function, it plays a critical role. And what's the role? This is a function that converts from unsigned short integer or in host byte order to network byte order. So if it was little Indian, it will convert it into big Indian. Okay, I'll just want to illustrate this, okay, just by writing a very small program. Now let's quickly, verify that this is true. Dialog to theek hai, but we have to write a program, no? So let's write a program called print byte. Processor that I have is my machine, my processor. Processor matlab Intel, my Intel processor. Intel processor is little Indian. So देखिए little Indian में कैसे store होता है? I can just call this function that we have just written, print byte address of server port, size is 2. Okay, we just want to do 2 bytes. Okay, this is what we want to do. Then after conversion, we want to again print byte the same thing. Okay, so how? Let's compile this convert.c. What is this? So let's quickly do, probably here we have to put another star here. Okay, we have to compile this guy and let's run this. See, first what did we print? Host byte order, matlab little Indian mein how was it stored? 7 0. See this? And after conversion, what has it become? It has become 0 7.